Hey there, welcome to my channel Pi My Code, where I teach you blockchain development and machine learning algorithms using Python. Our today's topic is blockchain using Python, the beginner level. In today's topic, I'll teach you how to run a local blockchain using Ganache, how to check the balance of an account on Ganache, and finally, how to transfer some crypto from one account to another. One of the first things that you want to do is set up a virtual Python environment and create a Python file and name it main. Once you've done that, let's import some Python packages that we will need for this project. The one that we'll be using today is called Web3. Web3 is a collection of libraries that allow you to interact with a local or remote Ethereum node using HTTP, IPC, and WebSocket. You can find the web3.py documentation under this URL. And for today's tutorial, we'll be using some of the functions that are inbuilt into the web3.py library. So in order to uh, download Web3, go to your terminal, use your package manager, pip install Web3, click enter, and this should install the Web3 in your virtual environment. Once you've installed Web3, we can just check whether it's been installed properly by pip or not by checking pip list. All right, here you go. Down at the bottom, you see Web3 version 5.28. The next thing you want to do is download Ganache. Head over to this website, trufflesuit.com. Trufflesuit is a bunch of tools that help developers develop decentralized applications and to connect and to interact with Ethereum. And one such tool is Ganache. So Ganache is a software that builds a local Ethereum blockchain on your computer that can help you test your decentralized applications on it. Just click the download button and just follow the procedure, and it's quite easy to install the Ganache software. Once you've installed it, quickly open Ganache, click Quick Start Ethereum. You can see that Ganache provides you with 10 accounts, each having 100 Ethereum. This Ethereum is obviously fake, but it's pretty useful for doing testing. Once you have Ganache installed and Web3 installed as well, head over to your Python script and let's start coding. First, let's import Web3 library. Next, let's set up a provider. This is how the Web3 library talks to the blockchain. We can head over to the documentation real quick to see how this is done. So providers help Web3 connect to the local Ethereum node, in our case, the Ganache node, and there are three ways to do it: the IPC way, WebSocket way, and HTTP way. For today's purpose, let's do HTTP. If we scroll down to HTTP provider, we can see that we could use this function, HTTP provider, to connect it to the local Ganache node or Ethereum node in general case. So let's copy this code, paste it over here, call it Ganache URL, head over to the Ganache software, you can find the URL over here. Let's change this to smaller case Web3. And now let's check if Web3 is connected to our local blockchain or not by calling print Web3 is connected. Head over to your terminal and just run the script. So Python main.py. All right, we can see that it returned true. That means we're connected and good to go. Now let's try to get the balance of the first account on Ganache. In order to do that, we will be using the getBalance function from the Web3 library. Head over to your script and say balance is equal to web3.eth.getBalance. And inside we will need to provide the account address. Open Ganache, copy the account address from here, paste that in. Let's print it and check whether we are able to get the balance. Head over to the terminal, just clear this, run the Python script again. All right, we can see that the script is returning the balance. However, the balance isn't way at the moment and we need to convert it to ethers. The way to do that is by saying balance ether equal to from way and convert the balance to ether. Let's print that. Okay, we can see that the code has printed balance in ethers and on top in way from before. Let's clean up the code a bit and just make a quick function to calculate the balance. We don't need this anymore. Balance. Let's create a function called balance, which takes the address of an account and then uses getBalance to get the balance of the input address. And we can also print this in ether. Let's assign a string variable to the account1 address. Let's call the function and see if it works. So balance count1. Head over to the terminal. Sorry guys, I think we need to convert this into a string. There you have it. So the balance of account, this is our first account over here, is 100 ETH. We can similarly call account 2. And call the function on account 2. Head over to the terminal. run the code again. Perfect. So at the moment now we get the account balance for both the accounts and they're 100 ethers each. In the next step, let's try to transfer 10 ethers from one account on to another account. Let's again have a look at the documentation to see how to perform a transaction. On the Ethereum network, the transaction is a three-step process. In the first step, we create a transaction variable and assign all the transaction inputs as you can see over here. Then in the second step, we sign this transaction using the private key of the account. And finally, in the third step, we send the transaction to the Ethereum node for broadcasting. Now let's head back to our Python code and code a transaction similar to the one shown in the documentation. Here I've just created a dummy variable of the transaction, and now I will go step by step and fill in all the inputs that are necessary. The first one is nonce. So nonce is an arbitrary number. It's a unique number that is used for cryptographic communication and it's essential for mining. So for our purposes, we could just get the transaction count for the account 1, and each time you do a transaction, it'll be a unique number which we can assign as nonce. So let's create the nonce variable, transaction count. So first time around, it's going to be 1, then 2, and so on. We can get the transaction count of account 1. Put this over here. So the second input is the recipient's address, so which is account 2. And the third one is how much ether or how much weight do we want to transfer from account 1 to account 2. So for our example, let's say 10 ethers from account 1 to account 2. The fourth variable is the maximum gas units that the transaction will use. In today's tutorial, I will not be covering the details about gas and gas price. So for our purpose, let's put an arbitrary number of gas units and the gas price in way, let's say 50. Let's print this once. Okay, looks like the variable is fine. Now let's move to the second step, which is signing this transaction. We can do this by using the function sign transaction. Put in the transaction variable. And the second variable that we need is the private key of the sender. If you head over to Ganache, to get the private key, you can click Show Keys over here on the right. For account 1, copy the private key over here. We can create a new variable, name it account 1 private key. Assign that variable here. And let's do the final step, which is sending the signed transaction to the Ethereum node. The way to do that is through the function send raw transaction. And the send raw transaction function returns the transaction's hash. So we can take that into a variable. Here it's important to note that we need to add the hexadecimal transaction code of the signed transaction, which can be retrieved using the variable signed transaction dot raw transaction. That's it. And then we can get the transactions hash code and print it. And there you have it. Now we have prepared all the three steps of the transaction. We can quickly call our balance functions over here to show balance of account 1 and 2 after the transaction is completed. Now let's head over to our terminal, call the Python script again, and there you have it. So we started off with 100 ethers each, then we transferred 10 ethers from account 1 over here to account 2, and a bit of gas was deducted from account 1. Finally, let's open Ganache and see if the transaction was successful. There you have it. 10 ethers from account 1 got transferred to account 2. And if we see the transaction details, we can see that we printed out the same transaction hash in our terminal.